Today we're going to look at a method for creating dripping blood like this that you see on screen right now. So we can see what's happening here in the perspective view and in the render view. And this is being done using two particle systems and some expressions to move particles down a surface. So let's take a look at how this works. And we don't really need to render right now, so we'll just delete that. And I'll rebuild it from scratch. But first, let's just take a look. So we have a polygon plane here, and it has an emitter attached to it, and it's emitting a particle. That particle is being moved down the surface using an expression. And then that particle is emitting another set of particles which are being left behind that create this trail. So it's really the second set of particles that we're rendering. And in fact, we're converting this particle to a mesh so we can apply our shaders to it. And there's nothing really, there are no expressions to write for the second particle, just the first. So let's recreate this from scratch and see how it goes. So I'll delete everything except for this plane, and there's the poly surface. So we want to, I just have a plane that has a little bump in it. I want to turn this into an emitter. So we'll go to nParticles, emit from object, and the emitter type that we want is a surface emitter, and then we'll create a new solver for this, and this will be, we'll call this lead emitter. And we want the speed just to be 0. And normal speed can also be 0, and just create that. So now if we play the animation, they're just born on the surface. And then they're just falling off. So they're born anywhere on the surface, and then they fall off. So we want this these particles only to be born at the top here. So this new particle that's created, let's call it lead particle, just to make it clear, because we'll have two particles in here. So in the emitter, lead emitter, if we open up the attribute editor, we have something down here called texture emission attributes. Now, one thing maybe I didn't indicate, but when I created that emitter, you should turn need parent UVs on. I think that was on by default for me because I did it recently, but if I emit from object again, need parent UVs, make sure that's turned on. So we should see this in the emitter. So you can turn it on after the fact too. Okay, so texture rate here, so we can enable texture rate and put a texture in here. So let's just do that. We're going to create a ramp. If we look at this object at its UVs, just a standard plane, so it's just got UVs as you would expect. And so the U direction is going along here. Yeah, so my U direction is kind of opposite what it looks like on screen. So U is going this way, but that's going down the geometry. Okay, so then we're going to use a U ramp to limit the emission of the particles, really just to kind of these top level faces. That's probably a little bit off screen for you. Okay, so I've got my node editor open here. Just trying to make this a little bit bigger. Okay, so here's my node editor, so let's just tidy this up. And we're going to create a new ramp. Oh, not a ramp shader. Ramp texture, misclicked there. So just a regular ramp, and we said that we wanted this to be a U ramp. And if we select this emitter, then we can middle mouse drag this ramp over to the texture rate and turn on enable texture rate. So if I play this now, what we should see is that particles are more likely to be emitted the brighter the surface is. So if I switch these around, and play the animation. So this doesn't always work right off the bat, and it's kind of frustrating, but I found that if you go in and change the rate from the emitter to another value, then it should start working. Yeah, so now you can see they're just being emitted at the top here. So I don't want these to fall down due to gravity. So I'll just select these particles, dynamic properties, and ignore solver gravity. So let's just see now. We should just see particles being emitted up here. Yep, and now they don't move or do anything. Okay, so that's great. That's what we want. So you might think that the texture emission rate option is not working, which I always found to be a problem. But it just depends on changing the emission rate for it to take effect. So if I go down to 50, I have noticed if you go down to really low values, it doesn't seem to work. So it works at 50. If I go down to 10, yeah, so they start getting born all over the surface again. I don't know why that is. I don't know if it's a bug or if I'm doing something wrong, but seems like 50 for me is kind of a cutoff point. If I go to 40, does it work? Yeah, so at 40 they start being born all over the surface. There may be a reason for this that I don't know, but we'll just leave it at 50. Okay, so now the next thing we want to do is get these particles moving down the surface. So we want them to stick to the surface first. So if we select the particles and then shift select the surface, we can go to our nParticle menu and make it a goal. The surface will be a goal for these particles. Just make sure the goal weight is set to 100. Now if we play the animation, you'll see them probably sticking to the vertices somewhere. Yeah. So what's happening here is that the particles are being born randomly on the surface according to that what the ramp allows. But then when you set a goal, by default they'll pop to the vertices. That's why you see them appearing regularly here. So our next step is to make sure that their birth position is the same as their goal position. So if we go into the particle shape and we see, where is it? Per particle array attributes and add dynamic attributes. So we want to add a couple of dynamic attributes. So we want parent U and parent V. This will record the location in UV coordinates where the particles are born. And then we also want goal U and goal V. So we can set the goal to that unique parent location. Just say OK. So they will show up now in the per particle array attributes, and we'll right click on goal U or goal V in the field beside it and write a creation expression. So this is very simple. You just say goal U equals parent U, semicolon, and goal V equals parent V, semicolon, paying attention to the capitalization of U's and V's here. Press create. There's nothing red down here, so we know that it worked. So now if we play the animation, it looks like it just did at the beginning. I think I'll probably turn off collisions in this. We don't want these particles to bump into each other necessarily. They should be allowed to merge and cross over and do stuff like that. It's probably not a big issue. Okay, so now we want them moving down the surface. So we're going to go to the goal U and V again. So I'll do runtime before dynamics expression, and we'll open up my expression editor. And in fact, you'll see that we can access the creation expression here too, and then runtime before or after dynamics. So what runtime means is that whatever we write in here will be evaluated on every frame. So we want this moving down in the U direction. So we're going to say goal U. And I'm just doing runtime before dynamics, doesn't matter. I could say plus equals. So that means goal U will equal itself plus some value. And that value will be, well, we could say 0 0.001. And remember that the U dimension goes from 0 to only to 1 at the end. So we're dealing in values less than 1, between 0 and 1. Press create, and then we'll play the animation. Right, so now you can see they're moving very slowly. So if we remove a 0, it'll be 10 times faster. Right? Okay, so that's pretty good. And you'll notice I made a bump in the surface here on purpose so you could see that they will travel over the surface bumps. So this is not dynamics doing this. This is just expression writing. Okay, so we could randomize this a little bit. So we can say rand bracket between that value or comma 0.02. So the rand function just looks at the two values in the bracket separated by a comma, and every frame will randomly choose a value between these. So it'll be a little jumpier, but a little less perfect. So they kind of speed up and slow down as if they're hitting something. That's going a little fast, but so let's change this to 0.05 and maybe 0.07. Yeah, okay, so that's good. So now we want to make these things wiggle back and forth a little bit. So goal U is moving them down this way, so goal V can move them side to side. So we could say goal V plus equals, well, what if we just did 0.001? You can imagine what will happen. They'll gradually move to the side as they go down. Right, so they're tending over this way, and then when they get to this edge, they don't know what to do. We could kill them when they get to this edge, but we're not going to just have them move consistently over. If I change this to a higher value, it'll be a little more obvious. Right, so now they're going over there. So we're going to do a different expression. We'll say noise times, so noise is just a random noisy, it samples a random noise to pick a random value. And then in brackets times sfrand. So sfrand is another randomizer, but imagine a sphere in 3D space. Sfrand chooses a value somewhere in that 3D space. So it's good for choosing vector values, x, y, z values, and stuff like that. I got this from somebody else's video, so I'm not claiming this is my own or anything. In brackets times time plus, and this is what I got from another video. If I can find it, I'll link it. Particle ID. I don't think this will work. I think I made a mistake here. Oh no, it worked. So particle ID is just every particle has its own value, its own identifying value, and so this just kind of gives each one something slightly different than all the rest. So it's sfrand, it's a sphere of a radius of time, particle ID, so it changes over time. Right, so they go crazy. So we can just multiply the whole thing by a smaller value. So you can kind of see they're going back and forth. Maybe I'll edit this. Right, so now you can see they're kind of moving side to side. It's a little bit too much. So depending on what you want it to look like, you can change this value. So now they're moving a little bit side to side. I'm going to make it just a little bit more. Okay. I am going to save. Now, so we have these things moving down. We could kill them at the end by putting an if statement So we'd have to, hold on, let me pause for 1 sec. Okay, I'm back. I just had to check, make sure I actually knew how to do this. But so if we want these lead particles to die after a certain amount of time, there are a couple of ways we can achieve this. We can go into the particle shape and set their lifespan mode to constant, so they would die after a certain amount of time. And whatever value you put in here is in seconds. And then you could do random range, so it could be 1 second plus or minus whatever you put in the lifespan random. Or we can do this with a per particle attribute. So we can tie it more directly to the goal U rather than simply a certain time. So we can change this to lifespan per particle only. And then down here in the per particle array attributes lifespan PP, we can go to the runtime before dynamics or the creation node. So what I've done here, you can just see, is that I've typed lifespan, whatever this value is. So mine is lead particle shape. Lifespan PP has to match this wording exactly, the letters, equals 10 semicolon. So when each particle is born, it's given a lifespan of 10 seconds. And then in the runtime before dynamics, I wrote a simple if statement. And so if bracket lead particle shape dot goal U is greater than 0.9, which would be close to the bottom edge, 90% of the way, then curly brackets, lead particle shape lifespan PP equals 0, semicolon, close curly brackets. And so now if we play this, the particles are born and they travel down. Then when they get down to 0.9, they just die. So this is a good way to keep the particles from filling up your scene if you want the blood to drip for a long time. So this way, if your camera is like this and you're not going to see anything below there, have the particles be killed. Okay, let's save. So now we want to emit a new particle shape from this particle. So select the original lead particle shape and go to FX, nParticles, emit from object again, and then change it to Omni, create a new solver, and I'll call this trail emitter. And again, I've learned this from somebody else's tutorial. It's nothing that I've made up. We don't need parent UVs because it's not being emitted from a surface. We want no speed. Yeah. Great. So now if we play the animation, so it's just emitting these. It seems like they have speed. Do they? Maybe not. Omni emitter. Okay, well, we'll take this new particle. We'll call this one trail particle. And we will go into its dynamic properties and tell it to ignore solver gravity. And we will make it not self-collide or collide. You might have different settings because under nParticles, there are these create options, and yours might be set to something different than mine. Mine's set to balls, which means they are self-colliding and colliding. If you do points, it won't be. If you do cloud, it won't be. But that can all be changed after the fact here. Right, so now this is more of what we want. So now these particles don't have to stick to the surface. However, if your surface is moving, then that would be a problem. This works if your surface is static, because these new particles are not being created on a surface, so they can't be made to stick to it. I guess there are ways that you could do that, but I'm not going to talk about that here. So you can see that they will live forever, and we'll just get a constant trail, and maybe that's what you want. That could be useful. But we're going to change this a little bit. So our lifespan is set to a random range of, let's say, 5 seconds, give or take 1 second. And the radius is 0.2. Let's make that bit bigger. Okay, and then we want them to taper off over time. So what's tapering really is each individual particle, according to its age, over its lifespan, it should get thinner, and we can use radius scale for that. So this thing here. So if we set it to age, I honestly don't really quite understand how this works, but you kind of get always a consistent length. If we set this to normalized age, though, then we can get something more in line with what the actual age of the particles are. So they'll kind of trail off. You can see we can run into some problems if we hit the side, but let's not worry about that. Okay, so almost there. I'm going to make these a bit bigger. So if we adjust the age, now this is the thing I don't quite understand. Let's see. Yeah, so now we're getting shorter trails with shorter age, so that makes sense. And we're getting kind of a nice effect here. That depends if you want them to totally disappear, like it's just a single moving drop. You can do it this way, or just give it a longer lifespan if you want them just to make long streams that slowly kind of taper. It really depends. So I'm going to set mine to some kind of middle ground here, maybe 5. And of course, we can still go back into the initial particle, which is somewhere here. Trail particle. Oh, lead particle here. And we don't really want to see the lead particle, but we can still go in and adjust its settings. So if we wanted to go into its runtime before dynamics and make it move a little more slowly, I could change this to 0.3 and 0.4, edit. So now you can see it's moving a little more slowly. And we can change this side-to-side motion a little bit. I always have to click edit to complete that, so now it's not moving as much, just a little bit. Maybe we want it a little bit more. Oops. Don't hit return, just hit edit. That looks pretty good. Okay, I'm going to save my scene. Now the last thing we're going to do is just convert these, well actually what we're going to do first is hide the initial particle, so the lead particle we don't need to see. And so if we go into object display and just turn it into an intermediate object, then it won't show up and it won't render. Now these trail particles, we can select these and go to modify, convert nParticles to polygons. We'll get something like this, and in that particle shape node we can go into output mesh, change this to quad mesh, smooth it. Let's just get in a little bit closer here, and then we can reduce the maximum or the mesh triangle size to, let's say, 0.2, so we can approximate the shape a little more, and then just play around with the blobby radius scale. You probably want this kind of small, and then turn the threshold up so you can get more of a trail here. And you can reduce this mesh triangle size even more if you want to. Then we get kind of a nice effect. So you could render the particles directly if you want with Arnold. So if you want to do that, these trailing particles, you can see that they're set to an intermediate object themselves because I converted them into polygons. Where is it? But if you wanted to render the particles directly under shading in the particle shape, we can well, it already is, but leave it at blobby surface, and then Arnold can render them. However, you don't have as much control over the shaders as you do with this, and also the way they kind of interact with each other. Although it might be good enough for what you want to do. And then, but because this is a shader or a piece of geometry, I can just assign a normal material. So I've got one made already. And then we can render this and see what it looks like. Yep. So to make it look like blood, all I did here was, if we just take a look at the shader, so it's just got its transmission turned all the way up. It's got a color of red, and then I used the depth to go to a scatter color. And so that allows, it depends on the scale of things in your scene. I can hit 3 to smooth this out, but Maya might get angry. So I'm going to say no. And if we just render this, it allows it to look a deeper color the thicker it is, and kind of thin out here. So you can see up close kind of falls apart, but you could improve this by hitting 3 on your keyboard if your computer can handle it without crashing. Or we could go back into the trail particle shape and into the output mesh here. So we could reduce the max triangle resolution or the mesh triangle size. So if we reduce that, right, so it's the mesh triangle size, not this. But we have to increase this too. So between those two, you can get a more refined kind of mesh. And then also the quad mesh and the smooth iterations here. The more you do this, the slower it's going to be, though. Oh, this is playing pretty nicely. But as more of the polygon surface is produced, you can see how much it's slowing down. So I'm going to reduce this. But because the particles being emitted are all part of the same particle shape, they can actually merge together when they run into each other. There you go. You get these kind of interesting, nice interactions between these things, and still a lot of control over how this goes. And if we were to change the surface now, because this is not dynamics, it's not being stuck to the surface based on dynamics, but based on the UV position, we can still change the nature of the surface. And see that it will still follow. Even when changes are made here. So the surface could deform. But if it deforms over time, it will leave those trail particles behind. That would require a different solution. Okay, hope you find this useful. Thanks.